And so when we look at these nor'easters, nor'easters have a certain identification pattern to them, and that's primarily what we're going to be talking about. And so when we look at the surface low pressure pattern track, we notice that many of them either originate down towards the Gulf of Mexico, cross over Florida, and ride up along the East Coast and impact New England that way, or they work their way out of the Midwest and they will move just south of New England and they will impact New England that way. So there's really just two areas of low pressure origin, either down in the Gulf of Mexico or one that comes out of the Midwest. Okay, and we're going to talk about the two types of pressure patterns because they do have names. And so eventually these nor'easters will end up in the Canadian Maritimes, but not before leaving a whole bunch of snow, ice, and a lot of mess behind. So when we look at the storm development climatology, where do these storms really originate from? So like I said, one of the original points would be out of the Gulf of Mexico. We have this piece of energy that crosses over Florida and really just starts to develop just along the coast of Georgia, South Carolina, along that region. And then the second area for development of a low pressure system that becomes a nor'easter would be on the leeward side of the Rockies. So this is what's known as the cyclogenesis climatology. And cyclogenesis really is just a fancy word for the development of a low pressure system. And so remember how a low pressure system develops. It's a boundary between cold air to the north and warm air to the south. It develops as a weak stationary front. It's just a very low argument between cold air and warm air. And then what happens is that you have a little wave that rides along the stationary front, the Coriolis force takes over, and then you have this definitive circulation where warm air is moving north and cold air is moving south. And so here you have a definitive warm front and a very identifiable cold front. And so we never really talked about what actually this little wave is, this little wave that develops. And so what actually causes that little ripple? So in the atmosphere, we use the term gravity waves, and those are essentially the little ripples that create low pressure systems. And so what a gravity wave basically is, it's oftentimes caused by orographic lifting, where air will come and hit a mountain ridge. It will be forced to rise. It will rise up over the mountain. It will be cooler than its environment. It will sink back down towards the surface. It will get heated once again. It will become unstable. It will rise again. It will cool and then come back down towards the surface. So it adds this very nice ripple effect in our atmosphere. And sometimes you can actually see them here. If you've ever seen clouds like this, you can actually see this ripple effect. Here you can see a mountain ridge out behind this image or out in the background of this image, and here you can see how it's pretty clear behind this mountain ridge, but then as you get closer to where this person is taking the picture, you can see how all these little fractal wave sheet clouds develop. So that's very interesting, but oftentimes they will look like this, and here you can see just a very nice wave that's generated in the atmosphere. So that's another way of what a gravity wave looks like. And so remember that it's the vorticity that will cause the rotation in our atmosphere that will spawn these low pressure systems. So remember when I said that vorticity is the parents and low pressure systems are the children? Well, you can think of gravity waves being the grandparents, vorticity being the parents, and the low pressure systems being the children. So remember, vorticity is really just like rapids in a stream, where when we look at a 500 millibar map and we look at vorticity, we notice that the low pressure system is always just slightly ahead of the area of strongest spin, or the area of highest vorticity. And so here we've seen this image before, and so this is just some little review.